Okay, Ladi, you say hi.
Hi.
Say hi, everyone.
Hi, everyone.
Say, hope you enjoy this.
I hope you enjoy this.
They'll figure it out. Okay, I just wanted to do a few review questions first. One of them is determine log b 75 a cubed b when, and then they give you what different things stand for. So when log b5, log base b of 5 equals 3, log base b of a equals 2, log base b of 3 equals a half. So we somehow have to transform. Carry on. No, you go. We sometimes have to transform this into being B5, BA, B3. So if I look at the 75, I somehow have to get it to be 5s and 3s. If I can get it to be 5s and 3s, then I can expand it and have log B5 and log B3. So 75 is 25 times 3, right? Which is 5 squared times 3. And then times a cubed times b. And then we're taught that when we have multiplications, we can separate it by additions. So I'm going to get log base b of 5 squared plus log base b of 3 plus log base b of a cubed plus log base b of b. Now, a lot of people try and replace right now log base b of 5, they replace it with 3 and then square it. You can't do that. I need to replace log base b of 5. So what I have to do first is actually drop this 2. The answer, if you take the answer and square it, will be there. It's wrong. So you need to take your exponent and you need to drop it in front. So we're going to get log base, 2 log times log base b of 5. b of 5, oh wow. Plus log base b of 3. Don't move anything because that's good. Plus 3 log base b of a plus log base b of b. Now I can replace log base b of 5 with 3. So it's going to be 2 times 3 plus log base b of 3 is a half plus 3 times log base b of a, which is 2. And then log base b of b, this is to the exponent 1, and b to the 1 is just 1. Remember when I told you when this is b to the something, your answer is just that something? So then we can put our stuff together. So we get 6 plus a half plus 6 plus 1 equals 13 plus a half, which equals 26 over 2 plus a half to get common denominator. So it's 27 over 2 would be the answer. And you have to be able to do ones like this, where you separate them. That's one of the questions. The other one I already gave a practice question for, but I want to practice it anyways. So you have, for example, 3 to the 2x squared plus 6x over 27 to the x squared plus x equals 9 to the x plus 3, let's say. I can make them all, and it'll say solve. I can make them all be base 3. So this will be 3 to the 2x squared plus 6x. 27 is 3 to the 3, x squared plus x. And then 9 is 3 squared, x plus 3. And then we get 3 to the 2x squared plus 6x over 3 to the 3x squared plus 3x equals 3 to the 2x plus 6. And then this is where everyone drops the exponents off. But you can't drop the exponents until you have base equals base. So you have division. So you're going to need to subtract. Because when you have two bases and you have division, you subtract. So you get 2x squared plus 6x minus 3x squared plus 3x equals 3 to the 2x plus 6. And so we get 3 to the 2x squared plus 6x minus 3x squared minus 3x equals 3 to the 2x plus 6. Put those together, you get 3 to the negative x squared plus 3x equals 3 to the 2x plus 6. Now I actually have two bases that are the same, so I can set the exponents equal. So I'm going to get negative x squared plus 3x equals 2x minus, 2x plus 6. Subtract 2x. Oh, I want to make it positive x squared. So I'm going to add x squared minus 3x. And I'm going to get 0 equals x squared minus x plus 6. And then I can factor it.
Mom,
X minus 3. What's up, hon?
I actually blew the bubble.
Oh, you blew a bubble. Good job. Okay, go sit down.
I will tell you.
Okay, x equals 3 and negative 2. And because this isn't a log, both of them will actually work. So there's that.
I'll work with you.
Moving out of your way.
Didn't interfere too much.
You're good. It's a review for them so they can suck it
Don't snip.
up.
Mom, you
Yeah, I did. Just draw, Lundy. Okay. Then we want to go through word problems. So if we did increasing or decreasing word problems, we'd have F, or appreciating and depreciating. F equals I, 1 plus the interest rate if it's appreciating, and then 1 minus the interest rate if it's depreciating. How you know to use this one and not the compound interest formula is it doesn't have the word compounded in it. Okay, so how I could ask these ones is it doesn't have the word compounded. I could ask you for the initial value, the final value, the interest rate, or the year, because n is always in years. So if I want months, I'd have to times it by 12, etc. So what we could do is often you're asked to find n because that's the exponent, but you could be asked to find I or f or little I. If you're asked to do any of those, you can just use algebra. If you're asked to find n and you're asked to do it algebraically, you'd actually have to convert it to a log. But you can y1, y2 these. Remember that as well, if it's not a written response. So what they could do is they could say, initially I had $200. So initially I had $200. Interest per annum is, so initially, 200. Okay, and it could say at 5%, which would be amazing. You invested $200 at 5% per annum, per A, which means per year, which is always how it is. So I'm going to go 1 plus 0.05 because it has to be in decimal. Just divide by 100. And then now they could ask me for the final value. If they do, I just fill my year in and just do the math on the right-hand side. Or they can give me the final and ask me for how many years or how many months. So the final value is how much money you had initially plus the interest. So if I said, how long does it take for this investment to make $50 interest? My final value would not be 50. My final value would actually be how much I put in, 200, plus the interest I made, 50, and I would come out with 250. So you have to watch if they say interest and not just final value. So I do 250. Now I told you the very first thing you should always do then is divide that initial over. Oops, and they're asking how many months. So divide by 200, and I'm going to get it to reduce to 5 over 4, because I can take a 50 out of each, equals 1.05 to the n. Now I could y1, y2 it right now, but I can also just convert it to a log. So the base of my exponent, which is 1.05, becomes the base of my log. What's with it doesn't stay with it, so I'm going to get 5 over 4 beside it, equals n. The only difference is if it was decreasing instead of increasing, so it was depreciating instead of appreciating, I would just go 1 minus 0.05. So I'm going to type this in. And I'm going to go math, arrow up, 1.05, and then 5 divided by 4. And I get 4.57 years. Now I'm not going to round it to 5 and then times it by 12 because I can only round in the very last step. So I'm going to take that years and I'm going to multiply it by 12 first, then round it. So it takes me 54.8. So that's actually 55 months. So this would take 55 months to make $50 at that interest rate. Okay, how did I know to use this formula instead of the CP? Because there was no words compounded in there. So how does it sound if I do the same thing? And this would be a simple interest. How would it be if I wanted it as a compounded? Well, it could be the same question. I could say, okay, I have $200 invested. The garbage right there. My daughter's here. Say hi, London. Say hi again. If say it louder, they can't hear you.
Hi.
So you do $200 invested. Okay. We want to make $50 interest. So it sounds the same.
Or 100.
At 5% per annum. But I'm going to actually follow behind with compounded semi-annually. So the first one was a simple interest question. This one has the words compounded in it. So the other formula we would use if it was population growth or if I was declining in population. This one I use if it has the word compounded in it. If it has the word compounded, I use the formula with compounded. And now I'm going to ask for how many months. So what's the only thing that changes? I'm going to have 200 initially. I'm going to have 250 final. I'm going to have 1 plus my interest rate, which is 0.05, but I'm going to divide by that too. Because compounded semi-annually, CP is 2. Compounded monthly, 12. Because it's how many times a year? Compounded quarterly, 4. Compounded annually, once a year. And then my n, which is normally up here, I'm going to multiply by CP. So I'm going to end up with 2 times n, or 2n. So what I'm going to get is (0.05) divided by 2, which is 0.25. So I'm going to divide the 200 over like I did before. So I always divide my initial over. I'm going to get 5 over 4 equals, and this time instead of 1.05, I'm going to get 1.025. Okay, and it's to the exponent 2n. Then I can convert it to a log again, or I can y1, y2 it if it's not a word problem in the written response. And I'm going to get log 1.025 to the 5 over 4 equals 2n. And then I just have to divide by 2. N equals, type it into my calculator, 1.025 to the 5 over 4. Hit enter, then divide by 2. And it's going to be 4.5184, so it's a little faster. And I take that and times it by 12, and it's going to be 54.2. But I always have to round up because I need to get at least $50. So it'd be 55 months. So it ends up being the same in this case, but it actually was faster. Now, sometimes they'll ask for the initial. If they do that, what they can do, let's say it's just a decreasing question. So they say, initially, we don't know how much we have. We have, in the end, 200 fish. Okay. Initially, I had a certain amount. We don't know. The fish in this pond are getting sick, so they're declining by 5% per annum. So I'm going to go 1 minus 0.05. So if in 3 years there are 200 fish, how many were there initially? So they could ask this. Literally just put together what you know. So you have 200 equals I, 0.95 to the 3. Please, because this is below 1, we know it's decreasing. Please don't go y1, y2. This is just I times this. So just go 0.95 to the 3 and divide it over. So we're going to go 200 divided by 0.95 to the exponent 3. And we're going to get 233.27, which means we had 233 fish initially. So if they ask for something initially, you're not going to have to convert it. You only have to convert to a log when you have, where you're needing the exponent. The last one is doubling, tripling, half-life questions. So that's the only formula you have actually on the formula sheet. It gives it to you as y equals a b to the t over p. Like I've told you before, don't get stuck on what the variables are because it doesn't matter. We just need to know that this is final, this is initial. If it's doubling, b is 2. If it's tripling, b is 3. If it says it has a half-life, b is a half. P is the period of how long it takes to get here. So if it says it halves every 2 minutes, then P would be 2. Or if it doubles, the bacteria doubles every 30 seconds, then P would be 30, because that's how long it takes to double. And at the end of 30 seconds, my bacteria would be doubling. T is the time to reach final. Okay? So we're going to look at a question. We're going to say we placed 2 bacteria cells in a petri dish. Hey, baby. You got back? She just left for a little bit. Okay, so 2 bacteria cells in a petri dish, and they double every, let's say, 10 minutes. Okay. They double every, okay, go, Lundy. They double every 10 minutes. How many years, what the heck? How many minutes? Yeah. How many minutes until there are at least 1,500 bacteria? And the reason why I said minutes is T and P have to be in the same units. So if they're not in the same units, you'd have to convert them to be in the same units. So because one of them is in 10 minutes, then the question should be asked in minutes. If it's not, you're going to find your answer in minutes and then convert. Okay, so there are 2 bacteria cells initially. So that would be in my initial spot. 2 bacteria cells. And they grow into 1,500 bacteria. So that's going to be my final. It says it doubles, so I'm going to put a 2 in here. If it halved, I'd put a half in there. If it tripled, I'd put a 3 in this spot right here. It doubles every 10 minutes. That means every 10 minutes it's doubling. It's doubling. It's doubling. So that's the period. And they want the time to reach the 1,500, the final bacteria, so T. Then we still just divide our initial over. So we're going to get 750 equals 2 to the T over 10. And then you could y1, y2 it. But we'd have to make sure our y max is at least 750, or you're not going to see that horizontal line at 750. Or we can log it. So I'm going to do it with a log. So I'm going to go log base. The base of my exponent becomes the base of my log. So log base 2. What's with it doesn't stay with it. So I get 750 beside it equals t over 10. And then I'm going to multiply by that 10. And then I can just type it in, and I'll get in minutes how long it takes to reach that 1,500 bacteria. So I would go 10 math log base 2 of 750. And it would be 95.5 minutes. And to the nearest whole number, it would be 96, because I said at least 1,500. Oops, I don't even know what I just did. So it would be 95.5 minutes. So since I said at least 1,500, I'd say 96 minutes to reach that.
Can I put this back? I just made it a color.
Sure.
How about I make all of them colors?
You can do one more, because we're going to be done right away.
I'm going to do some fast as much as I can do.
Okay. Okay, so that's the different formulas that we can have, those three. Like I said, I want to remind you, if I give you pieces of information, you're going to have to change the log into those pieces of information. If I give you these, you guys are really good if they're side by side to add them, but here you actually forget that you need to subtract the exponents. And at this problem, when you have 3, 3, and 3, you guys will just try and drop them off. You can't drop the bases off until you have full base 3 of something equals base 3 of something. Then and only then can you drop the exponents off. Okay? One last thing I want to remind you of, because I didn't get as much class time as I wanted with you guys, was if I gave you something like log x squared y plus log x cubed y z squared. Ooh, let's make it more. Let's go z to the half. Okay. Actually, instead of a plus, let's put a minus. Let's make it a little harder. Sometimes you guys don't spot you can put these ones together because they don't have bases. And I wanted to remind you of this, and I forgot to. Please remember that if they don't have a base, put the base 10. Then it might remind you to put me together. Let's make it a little harder. Let's amp it up. We can put it together right now, but say I put a 2 here. Okay? I can't put these together right now because I have that 2 in front. So I just want to remind you that if there is a number in front, you can't put them together, as I would tell you to do. You have to put the 2 up as the exponent first. Then put that in, distribute it in. So I'm going to get log base 10 of x squared y minus log base 10. And then I distribute that 2 into each of those things. So 3 times 2, x to the 6, y to the 1 times 2, y to the 2, z to the half times 2 is just z. And now they actually have the same base, which is going to put me together, and I have a plus 1 and a minus 1. So I can go log base 10. And do I need the 10s? No. But if I put the 10s, it often reminds me that I can put them together. So whenever I see logs without bases, I immediately write base 10 because often it will help me. On the bottom, I have x to the 6, y to the 2, and now just a z. The y cancels off one of these y's. The squared cancels off 2 of those. And remember, this is another thing I want to remind you. If the top completely cancels off, you still end up with a 1 times a 1. So I'm going to get log base 10 of 1 over x 4z. I don't need the base 10. If they wanted to, they could actually bring these exponents up. I just want to do a little reminder. I'm not saying they're going to, but I'm just concerned with, I don't know exactly what they'll do. They could bring these exponents up and they could write it as log base. I don't need the 10, But they could write it, they could bring it up and make it join the 1 and write it as x to the negative 4, z to the negative 1. They could. I hope they don't, but they could because that's legitimate math. Okay? I'm just showing it to you because I want you to remember that. And then there's the 3 rules that I told you with logs. If I'm ever give you log a to the 6, your answer would just be 6. Because what does your calculator do? It says a to the power of what gets me a to the 6. So it's 6. So that's a reminder. If it's a to the 6, it's a 6. If I give you log anything, smiley face and a 1 beside, it doesn't matter what I give you down here because we're going to ask ourselves, smiley face to the power of what is 1? And it's always going to be a 0. And then lastly, a log a to the a with a 6 beside it, your answer will be 6. That was the 3 rules I told you to star, and I wanted to remind you of. So there you go. That is what, if I had my extra days that I was supposed to have, I would have covered. So there you go.